This story concerns an event at a livestock fair held in the English port town of Plymouth in 1906. At this fair, an ox weight guessing contest was held, attracting around 800 participants. These included not only local farmers and butchers, experts in their field, but also casual gamblers and novices with no knowledge of cattle whatsoever. Each person submitted a guess of the ox's weight, with a prize awarded to the individual whose prediction was closest to the actual weight. As it turned out, the correct weight was 1,198 pounds. The winning guess, 1,207 pounds, came from a local farmer, while someone with expert knowledge won. The truly interesting part of the story begins here. Among the participants was Francis Galton, the scientist renowned for first proposing the concept of eugenics. Galton believed that reliable intelligence was possessed only by people of certain superior bloodlines, and he intended to use the contest's results to prove his theory. He obtained all the prediction slips from the organizers and calculated the average of all the guesses submitted. He hypothesized that the mix of expert and amateur opinions would cause the average guess to deviate significantly from the true weight, thereby validating his belief that the opinions of the ignorant crowd were worthless and should be dismissed. However, the actual result starkly contradicted Galton's expectations. Remarkably, the average of all the guesses was 1,197 pounds, only 1 pound different from the ox's actual weight of 1,198 pounds. Over 1. The phenomenon Galton inadvertently discovered that day has since been repeatedly validated. For instance, in a well-known experiment, often attributed to Professor Jack Trainer, 56 students were asked to guess the number of jelly beans in a jar. The actual count was 850, and the average of the students' guesses was 871, an error of just 21. Furthermore, on the American quiz show, Who Wants to Be a Millionaire, while an individual contestant's success rate is around 65%, the success rate when relying on the Ask the Audience lifeline, where the studio audience votes by majority, is an astounding 91%. This phenomenon, where a group's collective prediction often surpasses individual predictions, is explained by the diversity prediction theory. Why does this occur? Mathematically, the error of the crowd can be related to the predictions. A key finding is often expressed as crowd error equals average individual error minus variance, diversity. Here, variance measures the spread or diversity of the guesses. The more opinions differ from the average, the larger the variance. In the ox weight contest, because participants guessed independently, some overestimated and others underestimated. With many participants, these errors tend to balance and cancel each other out, leading to an average surprisingly close to the true value. This is the essence of what is known as collective intelligence, or the wisdom of crowds. To illustrate this intuitively, consider the popular election thought experiment. Imagine an election where all voters are ignorant people, lacking knowledge or sound judgment. If there are two major parties, these voters might choose randomly, leading to an approximate 50-50 split, meaning policies aren't effectively chosen based on merit. Now consider an election with 99% ignorant voters and 1% well-informed individuals. The 99% still vote randomly, giving each party roughly 49.5% of the total vote. However, the votes of the 1% informed minority can now tip the scales, significantly increasing the likelihood that sounder policies prevail. This is sometimes called the miracle of aggregation. However, economist Brian Kaplan argues that this theory often doesn't apply effectively in real-world politics. Conversely, It works remarkably well in systems like the stock market, where prices tend to converge towards their correct or efficient values over time. This difference is often attributed to the cost associated with an individual's choice. In elections, voters' opinions can be easily swayed by highly motivated activists, media narratives, special interest groups like corporations, and vocal personalities. The personal cost of casting an ill-informed vote is negligible. Thus, the electorate may not be a randomly diverse crowd, but rather a potentially biased one. Revisiting the diversity prediction theory's principles, if everyone in a group were to perfectly align with a single opinion, the diversity variance would be zero. In this scenario, the crowd's error would simply equal the average individual error, negating the benefit of the group. Stock market traders face direct financial consequences for irrational decisions. This incentivizes them to act in their own perceived best interest, which tends to preserve diversity of opinion and strategy. In voting, however, the low cost and low perceived impact of a single irrational vote make individuals more susceptible to following the herd or external influences. For the diversity prediction theory to function effectively, 4 key conditions are generally required. 1. Diversity. Individuals should possess some private information or unique perspective. Their knowledge and ways of thinking shouldn't be identical. 2. Decentralization. Individuals should be able to draw upon their own specialized or local knowledge and make independent judgments. 3. Aggregation. A mechanism must exist to collect and combine individual judgments into a collective output, e.g., voting systems, market prices. 4. Independence. Individuals' opinions should not be unduly influenced by those around them. American social scientist Scott Page notes that wise crowds often degenerate into irrational mobs precisely when this independence is compromised. Political polarization and stock market bubbles are prime examples of phenomena driven by excessive conformity and social influence. In summary, diversity possesses 2 crucial powers. It helps cancel out random individual errors, and it can amplify the influence of those with genuine knowledge or insight. This combination forms the basis of collective intelligence. These 4 conditions for harnessing group wisdom find application in various domains. For instance, the decentralized nature of buying decisions in large department stores or the aggregation capabilities of search engines leverage these principles. Conversely, systems lacking independence, such as might be found in dictatorships, represent failures to capitalize on collective wisdom. Ultimately, a group's predictive power is a function of both the average ability of its members and the diversity within the group. This implies that diversity is as critical as individual competence. As physicist Albert Einstein reportedly said, "Without creative individuals thinking differently from the crowd, society cannot progress." Science itself is a testament to this, built upon the collective intelligence accumulated through the contributions of great thinkers throughout history.